Hello guys, welcome to my YouTube channel MathTrans. Today we are going to solve a few questions from the Integral Cup 2025. I hope you like it. By the way, Integral Cup was powered by Vedant Ganit Samanavya. For more details, you can log into the following website, which will be shown in a few seconds. I hope you can see my screen now. So let's get started with the first question. So this is the given question. So now let me write it. Basically, in question, we have to start with the following integral. Arc tan x is just tan inverse x on x. So any guesses? How would you go about solving this? One way I could think of is to write the Taylor expansion of tan inverse x, which is nothing but x minus x cubed by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus, and this goes on till infinity. So therefore, tan inverse by x becomes this by x, and hence it becomes 1 minus x square by 3 plus x to the power 4 by 5 minus x to the power 6 by 7 and so on till infinity. This thing we need to integrate with respect to x for the following limits. And it is given to be a. So therefore, a is equal to, after integrating, this will become x. This will become x cubed by 3 square. This will become x to the power 5 by 5 square and so on. And hence, after putting the limits and giving the appropriate signs, we'll get a as 1 minus 1 by 3 square plus 1 by 5 square minus 1 by 7 square till infinity. Okay. But we are given the following relation, that pi square by 6 is equals to 1 plus 1 by 2 square plus 1 by 3 square 1 by 4 square up to infinity. So what I'm going to do is, as we can see that we only need odd terms, we'll club this, all the odd terms. And we'll club all the even terms. So it will become 1 plus 3 square, 1 plus 5 square, infinity, plus. Now, if you take, as all of these terms will be even and everyone will have 2 square common in them. So after taking 2 square common, you will get a series like this. Infinity. But we already know that this is pi square by 6. and this is 1 by 4. So if we take this to the other side, we'll get 3/4 of pi square by 6, which is pi square by 8 is equal to 1 plus 1 by 3 square plus 1 by 5 square, so on till infinity. Now, a is given as 1 minus 1 by 3 square plus 1 by 5 square minus 1 by 7 square till infinity. Now, if you add both these and then divide by 2, you will get a by 2 plus pi square by 16 is equals to 1 plus 1 by 5 square plus 1 by 9 square plus till infinity, which is the given answer. It comes out to be, let's see the options first. Yeah, so it comes out to be 0.616 plus a by 2. Okay, moving on to the next question. This is a very simple question. If you've learned Fourier series, especially in electrical engineering, it is very common for second years. So first of all, we'll use a trigonometric identity. Three x divided by 4. Okay. So therefore, this integral will become 3 by 4 times integral minus infinity to 0 sin x by x minus infinity to 0 sin 3x. I should have put in a dx here by x. Okay. Now, we know that sin x by x is an even function. So therefore, we can extend the integral and reduce it by half on both the sides. Sin x, and even this is also even function, sin of 3x by x. So we can increase the integral and let it range from minus infinity to plus infinity. And this will become 3 by 4 times sin x by x dx minus half of integration sin 3x by x dx, infinity to minus infinity. Okay. Now, this thing can be further reduced by suitable change of variables. Let 3x equals to some p. Therefore, your limits will remain same. And this integral will become this thing. Sin 3x will become sin p. X will become p by 3. And from here, we'll get dx equals to dp by 3. Okay. Therefore, this 3 and this 3 cancels. And we are left with, this will become I'm taking this half common from here and here as well. So half of 3 by 4, and I'm writing this integral as I. 3 by 4 times I minus I by 2. Sorry guys, I missed a 4 here. It should have been here as well. And this will become I by 4, which in turn becomes half of I by 2, which is I by 4. So we need the value of I, where I is equals to integral minus infinity to infinity sin x by x dx. Okay. Now we know that sine of pi t by pi t into e to the power minus I 2 pi ft dt. This integral will give you rect of f. Okay. It is very simple. So if you evaluate this integral at f equals to 0, then this will become rect of 0, which is equals to 1. So therefore, from here, we can now change the variable, let x equals to pi t, and by changing the limits, so pi into infinity becomes infinity, pi into minus infinity becomes minus infinity. And now changing the variable to pi t, and then dx will become pi dt, right? So this thing will become pi. Pi you can take outside, as it is a constant, and this integral, we know that it will turn out to be 1. So it is basically pi into 1, just pi. Therefore, the answer is pi by 4. You can calculate it and match it. Let's move on to the next question. This is a very simple question. So you just only need the knowledge of one thing, which is you have also done this in your maybe 10th standard, as far as I remember. This is the power of the exponent, make it bigger, and 1 by 2 by sigma square root dx. This goes to 1. Okay. This is the probability distribution function for a Gaussian random variable. Therefore, if I somehow bring this integral in this form, I know that it will be equal to this thing. So it is very, very simple. As you know that ax square plus bx plus c can be written as a times x plus b by 2a whole square minus b square minus 4ac by 4a, and then you bring this down. Okay, it will become 1 by a times, and I'll erase this. Okay, and now because this is the power of the exponent, we can pull this one out with the sign, and hence we will get e to the power minus p square minus 4ac by 4a times. Now this thing gives us the value of 2 sigma square as 1 by a. Okay, so therefore in this part where this integral evaluates to 2 pi sigma square, our answer should come out to be pi into 1 by a. Therefore it becomes this thing into this. This is our answer. Now moving on to the next question. We'll solve the following integral. Limits are minus infinity to 0. I hope you know L hospital rule will be required, and also integration by parts. It will be very useful in the coming questions. So now, in order to solve this question, we must look at this. If you can remember the expansion of this function, you'll get minus x square by 2 minus x cube by 3 and so on till infinity. In this question, they should have provided that n is positive. Now, let's carry on. If n is not positive, then when you put the limit minus infinity, and if n is negative, it will turn out to be a very, very big negative number, which is just not right. So now, replacing x with e to the power minus n, e to the power nx, we'll get to the power nx minus e to the power nx square, which is 2nx, 3nx, and so on till infinity. Okay. Now, after integration, you have to put limits. Lower limit is minus infinity, upper limit is 0. And after integration, this is the substitution. After integrating each and everything, each and every part, after integrating this, you will get minus e to the power nx by n minus e to the power 2nx by 2 square n minus e to the power 3nx by 3 square n This 2n will drop here, this 3n will drop here, and so on till infinity. I should convert it to integral here and put a dx here. That would be better. So now this integration, now we have to put the limits. The limits are from minus infinity to 0. When you put minus infinity, everything will go to 0. When you put 0, everything will go to 1. So you can take minus 1 by n common, and you will get 1 plus 1 by 2 square, 1 by 3 square till infinity. And you know this value, right? Just pi square by 6. Therefore, your final answer should be minus pi square by 6n. Let's move on to the next question. So, integration by parts and L'Hospital rule will be very useful here. I'll just write it down. By parts. Okay. Now, in order to integrate this, we'll consider this. I'll show you integration by part once, and after that, I think you'll be able to figure it out on your own. So, I'll integrate this function, and after integrating, it looks like this. So, integration by part says that split the main function in two different functions. Now, integrate one function first and write it as it is. So it will be this. Okay. And since it is definite integration, you'll put the limits 0 to infinity. Put a minus sign here. Now, to this function which you have integrated, multiply it with the derivative of the other function. So x to the power 5, differentiate it, and you'll get 5x to the power 4 dx. And now solve for this integral. Okay. We'll get that this turns out to be 0. And I am missing a minus sign here. After integrating this function, you will get this 1 by that thing. Okay. So this minus also comes in here. Now cancel this minus minus, and now it becomes 5 times x to the power 4 into ln of 1 minus e to the power minus x dx. Now you think that we are stuck. But from the above question, we already know that the log function already has an expansion, which looks exactly like this. I'll take the minus sign common, plus minus 2x by 2 plus e to the power minus 3x by 3. This is just expansion of log of 1 minus x, where I have replaced x with e to the power minus x, and so on till infinity. Okay. So after integrating it, you again apply integration by parts. Integrate this successively and differentiate this successively. Apply L'Hospital rule, and then you will get successive terms to be 0. And finally, it will come out to be 5 factorial into summation. When you put the limit, at infinity it becomes 0, and at 0 it becomes 1, and so it will become summation of whatever is given in the question as a hint. That reciprocal sum of infinite sum of the 6th power of the reciprocals of a natural number is a. So what it is saying, r to the power 6 is a, r equals to 1 to infinity. Okay. This thing is said to be a, so it becomes 120. 5 factorial is 120. Therefore, your answer is 120a. Okay. Let's move on to the next question. This question is, I think, one of the simplest question. You just needed to differentiate this function in C once. So when you differentiate it, so e to the power anything, this comes as it is. Next comes the power. Okay. So when you differentiated power, so now differentiation of, maybe I'll write it like this. This into differentiation of x sine x square. Yeah, you'll better understand it this way. Dash. So this thing will turn out to be differentiation of first one, and sine x square will remain as it is. Differentiation of second one will give cos of x square, then derivative of x square, which is 2x. This is into 2x, and the first one x will also come here. And you can simply say that it is a perfect integral. So therefore, putting limits to this, we just need to put limit to this, okay, because it is integration of this function, root pi. So when you put root pi, it becomes e to the power sine of root pi square becomes sine of pi, which is 0. E to the power 0 minus e to the power, when you put limit as 1, it becomes 1 into sine of 1, which is sine of 1, which is 1 minus e to the power sine of 1. Okay. This was a dicey question. Anyways, I'll solve it. I'll differentiate it. So after differentiating, we'll get this derivative of xy minus y square by 1 minus y ln x. Okay. Now this will, when you differentiate x, you will get y. When you differentiate y, you will get xy dash. So this y and this y cancels, and hence you are left with xy dash equals to y square into 1 minus y ln x. So therefore, now cross multiply xy dash minus xy dash into y ln x is equals to y square. Now divide by xy. Therefore, y dash by y, and shift this term to this side. So y dash by y will become y by x plus y dash ln x. Now you can see that it is a differential, it is a differentiation of this thing, and hence you can solve for it. Now, let's move on to the next question. Now, A, you can write it as, let's see first, let's expand this. I will become e to the power minus x square into e to the power ix. And you know that expansion to the power minus x square cos x plus I sin x. Okay. Now, note that e to the power minus x square, it can be split into this thing. A is equal to this thing plus iota times e to the power minus x square sine of x dx from minus infinity to infinity. Since the limits are same and this is an odd function, therefore it will go to 0. The integral will vanish to 0. This will go to 0 and therefore you will get A is equals to B. Moving on to the next question. We just need to find delta x first. I hope you have read the question. So let's move on. Okay. So given is a Gaussian curve. Let's make it Gaussian. This thing will be 1. So therefore this thing will be half 0.5. This thing is root of ln2. Okay. So the question is saying that to extend the straight line from here and then take any random point xy here and extend a straight line from here. This is known as point A. This is known as point B, which is general x comma y. Okay. And they are meeting at C. So now the area of this triangle will be given by, it is simple because it is a right angle triangle and this is x. So therefore you will get under root ln2 minus x as this length, and this length will be y minus 0.5. And area of triangle is exactly half of this. This thing is equals to delta of x. Okay. Now let's expand delta of x. Delta of x will be equal to half in root of ln2 minus x. I'll replace this with this. It was given the question. So you are taking it from the curve. Now del of x will become then 2 by 2 for minus x square. This is the first term. Then minus 1 by 4 into root of ln2. Second term. The third term will be minus x into e to the power minus x square by 2. Fourth term will be plus x by 4. Now, in the question, they are saying that this delta x is only ranging from minus ln2 to ln2. So extend its range from that to minus infinity to infinity, and we need to evaluate this integral. Delta of x plus root of ln 2 by 4 dx. Okay. So now we can see that this thing cancels with this thing. Now we just need to integrate this thing. So the remaining integral is this ln 2 by 2. Now e to the power minus x square dx, when integrated from minus infinity to infinity, as we know, it will give root pi. We have already discussed. You just need to substitute the value of a and you'll get this answer. Okay. Note that this and this are odd functions. So therefore its integral, because it is symmetric, will vanish to 0, and your final answer will become pi ln 2 in the root by 2. Okay. Now let's calculate this. This is a very good question, like, but still the numerical bound for this answer didn't match for me. I don't know. I don't think that I have made a mistake. Maybe you can help me in the comment section if I'll be making a mistake. So let's get started with this. For a convex function, so this is what is meant by convex function. It is facing upwards. In other words, f double dash x is positive, but they are asking it to apply to logarithmic function. And you know that log x is this way. This is concave function. Okay. So the inequality will reverse. The one thing that you need to know for the Jensen inequality is that the sum of all the lambda should be equal to 1. And that is where I think they made the mistake while writing the answers. So for logarithm, it will be written as function of summation of lambda I xi will be greater than equal to summation of lambda I into function of xi. Okay. Now we'll expand on this. This I'm writing it as this lambda, you can take it inside. It will be xi to the power lambda I. And this big pi means multiplication. Okay. And this thing is smaller than summation of lambda I xi. Do not forget that summation of all lambda I goes to 1. Now, as we need a lower bound, I'll substitute lambda I equals to 1 by 2n plus 1, and xi will become e to the power minus r by n whole square. Okay. So now writing it down, and substituting, we'll get 1 by 2n plus 1. I can take this common because all the lambdas are same, and my summation will range from r equals to minus n to n e to the power minus r by n whole square. This thing will be product of. Now, as all the lambdas are same here, I can raise it to a common power because it is in exponential. So e to the power minus r by n whole square, you know, and I'll take summation here. Okay, it is also ranging from minus n to n. Do not forget that. One by two n plus one. Now I should use my space better. Now we'll only look at this part and actually only at the power of it. So because exponential is raised to a power, now that power will be multiplied to the whole thing, right? R equals to minus n to n r square by n square, and minus sign also I'm taking common outside. Now I leave this to you to evaluate this sum, and I hope it will come out to be n into n plus 1 into 2n plus 1 by 6. I hope you remember this, but with a certain modification, it will be minus 1. Okay. Let's not forget the n square, which was already there. So now, when limit n tends to infinity, we can bring the limit here inside. This 1 is very, very close to, it will go to 0. This will also go to 0. This will also go to 0. Now we'll cancel this n. We can also cancel, rather 2n plus 1 goes with 2n plus 1. And this n will go away with this n. This 2 will take away 2 from here and 3 will be left. So limit n tends to infinity of this thing, it turns out to be minus 1 by 3. Okay. So now notice this is the very crucial part. Now I'm bringing this back, this original thing. Limit n tends to infinity, 2n plus 1 into summation e to the power minus r by n whole square, r equals to minus n. This is greater than equal to e to the power minus 1 by 3. Okay. But as limit n tends to infinity, this one will go to 0. And we are left with this thing into this thing, and we'll take to that side. Right. And this thing is nothing but the integral of Gaussian from minus 1 to 1. And hence we get the lower bound as this, 1 by 3. It was a good question. Let's move on to the next question. The 15th question. So it was quite good question. So let's first solve this integral. E to the power minus 2025. There's a x missing here. Not to worry about it. Dx. Okay. Now, first of all, we'll solve this as a function of a, where a is this minus bx dx, integration from 0 to infinity. Again, we'll use integration by parts here. Power minus bx minus b minus, put the limits. After putting the limits, you'll notice that it goes to 0. And then you differentiate the first function, you'll get a into x to the power a minus 1, and this integral thing minus bx dx. Okay. So now you can see that this will go to 0. You can apply L'Hopital, Rel Hospital, whatever you call it, and it will become a by b times. This is I of a minus 1. Clearly, now you can see that when you differentiate this thing later on, a minus 1 will drop and it will go on, and this will become I of a will become a factorial by b to the power a plus 1. It is very easy to see that. It will become this into I of 0. Okay. Now substitute. Now what you are getting is integration of 0 to infinity e to the power minus 2025. Maybe I'll let it be. It will be better that way. Bx into x to the power box y dx. So what will this turn out to be? This will turn out to be a factorial box y factorial, and I of 0. I of 0 is basically x to the power 0. So it is just integration of this dx. Okay. And this will give you 1 by b. Now, this will give you box y by b to the power box y plus 1. Okay. Wait. This will become, as you subtract, like when this I is holding for 1, I think it will become b to the power a. Because when a drops 1 times, its power, the power of b increases by 1. So when it will decrease by a times, it will become a. And after integrating this, finally I of a will become, because it is 1 by b, finally I of a will become a factorial by b to the power a plus 1. Yeah, now it is correct. So you'll get this. Now we have to take inverse of this. So it is basically b to the power y plus 1 by box y factorial integrated from, what are the limits? Limits are same, infinity to 0. But now box y is a function which we need to separate in different ranges. So this whole thing, maybe I'll call it f of b, f of b into dy. Because for this, box y factorial will become 0 factorial. Next, it will become uh, maybe let's not write it f of b, write it directly. So it will become b to the power 1 by 0 factorial dy. Let's also make it 1. Then 1, 2, b to the power 2 by 1 factorial dy. Okay, and this will go on till infinity. So what will you get? You'll get b plus b square by 1 factorial plus b cube by 2 factorial till infinity. Okay, which will simplify if you take b common. 1 plus b by 1 factorial plus b square by 2 factorial. I think you know what this is. This is nothing but e to the power b. And you know that b was 2025. So answer will be this. Was a good question, indeed. And hence, with this, we have ended mostly all of the questions. Some questions were dicey. And I hope you like the video. So please like, share, and subscribe to my channel. Thank you.